Welcome back to the GCSE Maths Pro YouTube channel. In today's video we'll be doing some final revision for Edexcel paper 3 for higher tier. Here are a few past paper questions that I think are on the topics that are more likely to come up in paper 3, having already seen paper 1 and paper 2. So starting from the easier ones, working our way through to the higher level ones, we've got Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometres an hour. Ollie took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for his total drive from Liverpool to Sheffield. So obviously this topic is speed, distance, time. So we can use our formula triangle. Now we've got two parts. We've got Liverpool to Manchester, which we know the distance for, 56, and we know the speed, which was 70 kilometres per hour. So you can see the only thing missing there is the time, isn't it? We might as well work out the times. So we'd have to divide 56 by 70, which as you can see gives you 0.8. Now that's in terms of hours because the speed was given in hours. So 0.8 hours. Then we've got Manchester to Sheffield. We've also got the distance, which was 61 kilometres. And this time we've been given the time, 75 minutes. To work out the average speed for the whole journey, we need to do distance divided by time. So I need to know the total distance and the total time. Well, I've got both distances, so the total distance would be 56 plus 61, which is 117 kilometres, divided by the total time. But because we want it in kilometres per hour, we have to also use the time in hours. We do have the 0.8 hours from earlier. We now need to convert this 75 minutes into hours. To convert any minutes into hours, I just need to divide it by 60. So as a decimal, it's 1.25 hours. So our total time is 2.05 hours. So now I just need to divide 117 by 2.05. And here is my average speed, 57.1, let's say to one decimal place. 57.1 kilometres per hour. For part B, we have Janie drove from Barnsley to York. Janie's average speed from Barnsley to Leeds was 80 kilometres per hour. Her average speed from Leeds to York was 60 kilometres per hour. Janie says that the average speed from Barnsley to York can be found by working out the mean of 80 kilometres per hour and 60 kilometres per hour. If Janie is correct, what does this tell you about the two parts of Janie's journey? Well, if we're going to find the average of these two, then that's just basically as if it was 50-50, isn't it? As if the journey was 50-50. Because finding an average between just two numbers is effectively like finding the midpoint, so it's as if they are just equally spread. So what does that tell us about the two parts of Janie's journey? That they are the same distance. If they weren't the same distance, which is obviously more likely in reality, then you would have to do a weighted average, not just a straightforward average. Question 6, I've just thrown in some column vectors because we haven't seen those yet. So vector A is 3, 4, vector B is 5, minus 2. Find 2A minus 3B as a column vector. So this is really straightforward. We just want 2 lots of A, 3 lots of B, and subtract them. So all we have to do is multiply both numbers in the first one obviously by 2, so that would be 6 and 8. Subtract, and then multiply this one by 3, 15, and that would become minus 6. And now just take away straight across to the top numbers and then the bottom numbers. So the top numbers would be minus 9. The bottom numbers, because it is a double negative, actually becomes a positive, so we're adding. So we've got minus 9 over 14. We've got another question 6 here. A new phone costs £679. The value of the phone decreases at a rate of 4% per year. Work out the value of the phone at the end of 3 years. So I wanted to show you this because it is the same formula basically as compound interest. Do you see how you've got a starting amount, you've got a percentage rate, and a number of years? It's the same setup. The only difference is obviously it's now decreasing. Sometimes they might refer to it as depreciating. Just think it starts with DE, so that's probably means decreasing. So all I need to do is use my same formula, but instead of where I normally would add my percentage, I'm going to take it away. So I'm starting with £679 times by 1. Instead of plus, you put minus 4 over 100 to convert it to a decimal, and then to the power of 3 years. This is the same as saying, well, we're starting with 100%, If we're taking away 4%, if we're losing 4% every year, then it's 96%, isn't it? But obviously you have to put it as a decimal. So you can just put the multiplier here. This is called a multiplier. You can just do that to the power of 3 if you feel comfortable to do so. That's also fine. I'm just showing you how to use the formula. And as you can see, my answer should obviously be less. It's decreased over the years. It's now £600.74p. I normally just do 2 decimal places when it hasn't told me how to round it, because obviously in the context of money, that would make sense. So £600.74p. Question 7, we've got some conversions now. So part A is to change 8,000 centimetres cubed to metres cubed. So the way that I would think to do this, unless you have got it memorised, which is also fine, is they've chosen 8 for a reason. Cubed is obviously volume. If you do the cube root of 8,000, you get 20. So what that's telling me is imagine that it was a cube to begin with, a cube. So all of the sides are the same, but it is 3D. That's obviously a badly drawn cube, but you get the point. What we've just seen is that each side is 20. So they've done 20 times 20 times 20 to get the volume. That's in centimetres though. So imagine you have the exact same cube. You would obviously know that 20 centimetres in terms of one dimension is 0.2 metres, isn't it? So how do I work out the volume? 0.2 times 0.2 times 0.2, that would be in metres cubed. Now it has given it to me in standard form. Obviously you can convert that. That would just be 0.008. So you can do that. If you don't remember the conversion, you can always think of it, okay, let's go to one dimension where I do know the conversion, then bring it back to 3 dimensions again for volume. Part B, change a speed of 180 kilometers per hour to meters per second. Okay, so we've got kilometers to meters and hours to seconds. So you can do them, I tend to do them separately. You can do them in whichever order you like. I normally do kilometers, meters first. So I know that there are 1,000 meters in every kilometer. So when I convert it into meters, it's going to be a much bigger number, isn't it? There's going to be a lot of meters in that same amount of distance. So that obviously means I'm going to have to multiply by 1,000. Obviously that's going to be 180,000 then, isn't it? 180,000 meters per hour. So we've gone from kilometers per hour to meters per hour. So that's kind of halfway. Then I think, okay, well, how do I go from hours to seconds? All right, well, think about how much distance you're covering in an hour. Well, an hour is quite a lot of time, isn't it? So quite a lot of meters. Obviously, that's why I've got so many meters. If I then go to second, how many of those meters am I covering in just 1 second? My answer is going to be a lot smaller, isn't it? So that's how I know, okay, the next bit I'm going to need to divide. But what do I divide by? Well, we're going to divide by 60 because there are 60 minutes in an hour. So that would make it into minutes. And then 60 again because there are 60 seconds in every minute. So effectively 60 times 60. And that gives you 50 meters per second. So just work through them step by step. Question 10, we're back to compound interest, but now it's the normal version. Naomi invests £6,000 for 5 years. The investment gets compound interest of X% per annum. At the end of 5 years, the investment is worth £8,029.35. Work out the value of X. So we're going to set up the exact same formula as before. Obviously now, because it's compound interest, the money is going to be increasing over time. So we're going to use the plus version. So you've got 6,000 times by 1 plus the percentage rate, which we don't know. So call that X over 100 to make it a decimal to the power of 5 years. What we do know is that that would then make £8,029. So now I've got my equation set up. Just think about algebra. I just need to solve for X. First thing I'm going to do is divide by 6,000, which gives me 1.338225. The next thing I'm going to do is root this power of 5. So taking my answer, I'm going to choose the option where I can change it to a 5 outside of the root symbol, and then I will get 1.059 recurring. So at this point, you could just basically round it to 1.06. I think that's fairly safe to say. Now, from here, you could probably guess what the interest rate is going to be. All I need to do is subtract 1 and then multiply by 100. So you can see we've got 6%. Question 13, I've got some circle theorems now. A, B, C and D are points on the circumference of a circle centre O. FDE is a tangent to the circle. Part A is to show that y minus x is equal to 90. Give a reason for each stage of your working. It's only 3 marks though. So it makes me think, strategically thinking about this, if it's only 3 marks, it's probably 2 marks for working, 1 mark for my reason. In that sense, and it's also question 13, I'm thinking, right, this looks complicated, but it can't be that complicated. It's not that many steps and it's not that far through the paper. So let's really try and think about it. I just need to set up an equation where I can get y and x together. So which angle within this whole circle theorem's shape can I write in terms of x and in terms of y, for example? So what I was thinking with y, and we've got a tangent, we've got here, if you ignore the other triangle, BAD is a triangle, we've got alternate segment theorem. Technically, y, this angle here, is the same as this outside angle on the opposite side. All of that is also y. Now how can I relate that to the x? Well, if you think about x, the x is here. OD is obviously a radius because O is the centre, D is the circumference. And then we've got a tangent. So on this right-hand side, it should be 90 degrees because we know that the angles between a radius and a tangent make 90 degrees. Do you see how technically the whole of that pink section there, that whole angle, is x plus 90? And because I know the pink section is also equal to y, I can first of all write down y is equal to x plus 90, and then just have a look at what they've got and go, well, they've obviously just subtracted x, haven't they? Now, there are loads of other ways to get to this point, loads of longer ways, which is fine, you can still get to the same point, but that's the most direct, I would suggest. Now, obviously they said you must give a reason for each stage of your working, so my working, I guess I could say ODE is 90 degrees because of the radius and the tangent being perpendicular, or some version of that, however you want to write it, and angle BDE as a whole, that's the pink one, is equal to y because of alternate segment theorem. So that would be my working out for part A. Part B, Dylan was asked to give some possible values of x and y. He said y could be 200 and x could be 110, because 200 minus 110 is 90. Is Dylan correct? Well, in terms of the statement, this calculation, that is obviously mathematically correct. But is he correct in the context here? We'll just have a think about it. Y represents this part here, the pink bit, doesn't it? And we've also got a tangent. Now, a tangent is a straight line. Technically, if I get a different colour, all of this can't be more than 180, can it? Because that's a straight line. So how can this smaller part be more than 180? It can't be, can it? So I would say, well, no. Dylan is not correct. You obviously must give a reason for your answer. So I've said, well, y has to be smaller than 180 because the tangent is a straight line. You could also relate to the fact that it's in a triangle. Y is inside a triangle, which is also 180 degrees. So y can't be bigger than that, can it? Something along the lines of that. Why, in this particular case, is it not true? So question 15, the area of triangle ABC is 6 root 2 meters squared. Calculate the value of x. Give your answer correct to 3 significant figures. So obviously here we've got a scalene triangle. We can't work out the area based on half base times height or base times height over 2 because this would be the perpendicular height, wouldn't it? Which we don't have. So then I'm obviously going to use my half AB sine C trigonometric formula. Subbing in all of the things that I know, one of the sides is, it doesn't really matter which is A and which is B, it's just the two sides they've given you, isn't it, basically? X plus 3, and the other one is obviously then 2x minus 1, and sine of the angle between them, which is sine 45, but that actually equals 6 root 2. So all I need to do now with that equation, I can almost forget about the context for a bit and just try and solve this. So first, what is sine 45? It is 2 root 2. I've also got this half here that I could multiply it by as well. So root 2 over 4 can be my coefficient. And then if I expand the brackets, I would get 2x squared minus x plus 6x minus 3. And that's equal to 6 root 2. Now, I could just, I'm not actually going to expand that out. What I'm going to do is just divide by root 2 over 4, bring it across the other side just to get rid of that fraction. That just gives me straight away 24. So this side I've got 24. Obviously, if I collect the like terms on the left, I would have plus 5x. Because it's a quadratic, I am going to move everything to one side where the x squared is positive, so just move the 24. So if I subtract 24, I should have minus 27. Now, normally I would try and factorise, but as they've said, give your answer correct to 3 significant figures. It's kind of hinting towards the fact that I don't think we can factorise because there's going to be loads of decimals. So I'm just going to go straight ahead and use the quadratic formula. So that gives me to three significant figures, 2.63 for the positive value. And if you just go back, just press the arrow so you don't have to retype the whole thing. Put minus instead, and then get negative 5.13 for the second value. So there are my solutions. Question 17. ONQ is a sector of a circle with centre O and radius 11. So we could write 11 here for the whole thing. A is the point on ON and B is the point on OQ, such that AOB is an equilateral triangle, side 7. So that's 7 for the triangle. This bit across here is also technically 7. Calculate the area of the shaded region as a percentage of the area of the sector ONQ. So to find out the shaded region, we have to find the whole sector area and then the triangle area. So the whole sector, we should have the formula pi r squared times by the angle over 360. Now you might be thinking, yeah, but I don't know what the angle is. They haven't told me. They haven't specifically given it to you. However, they've told us it's an equilateral triangle. And equilateral triangles are always 60-degree angles. This one's also 60. This one here, B, is also 60. So I do know what it is. So the area of the sector would be pi times the radius. Now remember that the radius of the actual sector is 11, so 11 squared. And then over 60 divided by 360. So I'm going to leave it in terms of pi because it's not the final answer. So we've got 121 over 6 pi. Now that is centimetres squared. So that's the sector. Now I want the area of the triangle. The triangle, I'm going to use the trigonometric area because I don't technically know the vertical height. Now, yes, you could go and use SOHCAHTOA to work out the vertical height if you really wanted. You could use even Pythagoras if you split it down the middle, but I'm just not bothered. So I'm going to go straight into half AB sine C. I think that's easier. You can do it the other way, but I think that's easier. So half times each side, which we know is 7 because it's equilateral for both sides, and then sine of the same angle 60. Which is another decimal, so I'm going to leave it in this format of the third, 49 root 3 over 6. To find the shaded region, I have to subtract these two. So the shaded region is the whole sector, which was 121 over 6 pi, minus just the triangle. So it's still my answer, so I might as well just use it as my answer. Now, obviously, it's given it to me as a decimal, so I'll write that down, 42.137 ... Now they have asked for the area of the shaded region as a percentage of the area of the sector. So percentages, we want the shaded region, which was our 42.137 ... over the whole sector, which was the 121 over 6 pi. To make it a percentage, obviously multiply by 100. So I'm going to copy all of my decimals from my previous answer. And because I wrote down the pi version of the sector, I know that that's exact as well. So then I've got that obviously times by 100. 66.5, they've said to one decimal place. 66.5%. So we've been given this information that we've got a few different straight lines. They've said that AN is equal to 2OA, so that scale there is like 2 to 1, isn't it, basically? And that's not vectors, I'm just writing down the scale, so don't get that mixed up with being a vector. Obviously a number on its own is not a vector, it has to have a letter. M is the midpoint of OB, that's fine. Then they've given us actual vectors, so O to A is the vector A, which now actually, given that, if that's A, then this AN must be 2A, mustn't it? So we've got that vector, the whole line would be therefore 3A. OB, try and draw here, is the vector B. And they've said A to P is equal to K multiplied by AB, where K is a scalar quantity. Basically just saying that AP is a smaller version of AB, isn't it? That's fine. Given that MPN is a straight line, find the value of K. So I'm going to obviously draw on that straight line as well. Any lines they mention that aren't drawn, then make sure you draw those on as well. Find the value of K. Now, this one's quite hard. I feel like it's just as long as you memorise the method, you might be alright. If you get a question like this, it might be asked for a ratio, it might ask for a scale, like this one's K as a scale. You need to find two vectors from the line that is crossing through the one that you actually want. So see how we actually want K, which is related to AP? So it's related to this line. We want the line that crosses through that, so that's the MPN line. You want two vectors from there, any two. I obviously normally choose the whole line because that's the easiest one, isn't it? So for example, MN as a whole if I were to go back, that's minus a half b, isn't it? Because I'm going halfway along that line and it's the wrong direction. Plus a plus 2a, which is 3a. That's mn. Then I want a smaller version, so either mp or pn, that's up to you. I normally start with the same letter. So I want mp. Now this is the one where we're going to try and get the k in there. So I can carry on the same way. Minus a half b plus just a, and then I want to come down here, don't I? I want to know ap. In order to know ap, I need to know ab, so let's write that up here. ab is quite easy, isn't it? Minus a plus b. And then ap, obviously I don't know the scale, the whole point is I'm trying to find it. But they've told us it's a multiple, isn't it? You're multiplying by k. So I can write it as this, k times minus a plus b. And then that is what I can add to my mp. The reason why I want that is because I want k in one of my two vectors. Because the whole point is I'm trying to find k, isn't it? So you've got that. Once you've got those two vectors from the line that crosses through the one you want, including the letter that you actually want to find, you need to, in this case, expand and simplify the second one so that I've got everything a together, everything b together, effectively collecting the like terms. So let's do that. Minus a half b plus a. If I expand this out, I get minus ka plus kb. Now you might be thinking, how do I put these together? Because that's 1a and then that's ka. Obviously 1 and k are not like terms. I would just factorize it. So what I mean by that is 1 minus k, a. See how I factorize this and put the a at the end? So the coefficient is all together because k is just a number. That's the coefficient. Same with b. I'm going to put the k first just so that the negative is second. It doesn't really matter though. Okay, so step 1 is to find the two vectors from that line. Step 2 is to expand and simplify anything you need to collect the like terms. Get a and b together. Because, let's write that there. Step 3 is then to create, this is a bit where I feel like it goes a bit left field, you know, like why are we doing this? Step 3 is to create simultaneous equations with the coefficients of a and b. Let me just rewrite this first one where a is first so we don't get mixed up. Okay, a and b there. Let me highlight this. We've got 3a and then we've got 1 minus k, a. Now, I can't write them equal to each other because if you look at the original vectors, mn and mp are not the same length, are they? mp is clearly much shorter. So there's also another scale along this line that I don't know. And this is a bit where people struggle because we're bringing in a second scale, a second letter that we don't really care about, but we technically need to have it. So I can't write down 3 equals 1 minus k because it doesn't, does it? It doesn't. It's not the same thing. So what I need is, let's say my scale, mp is x. Now I multiply it to the side that's easiest. This is the easiest side, isn't it? The 3. Doesn't really matter as long as you multiply it to the same side. X is the scale of how big mp is compared to mn. But I don't really care what that is. I just have to mathematically put it there. So that's that one. I also then need to do the same, but for the b coefficients. So b, we've got minus a half, and I'm going to apply this same scale, because obviously still talking about the same two vectors. Now do you see how I've got two equations, obviously simultaneous equations basically, because we've got x and k? I actually just want to find k, that's what the question's asking. I don't really care what x is. You might end up finding it out just anyway, but technically, in my head, I want to eliminate x in order to find k. If you think about how you do simultaneous equations, you normally eliminate one first to find the other. That's what I'm going to do. So in this case, you can either use elimination or substitution, it's up to you, but I want to find k. So I want to get rid of the x. So this one, the second one, I'm going to multiply by 6 because 3x and then minus 3x would match. So I'm going to multiply that one by 6, which will give me minus 3x equals 6k minus 3. And then do you see how these two would cancel each other out? Let's write that over here. So we've got 3x equals 1 minus k, then minus 3x equals 6k minus 3. If I add those would cancel, so that'd be 0. Now, just be careful because they're not written in the right order, are they? So we've got 6k plus minus k, so that's 5k. 1 plus minus 3 is minus 2. And now, do you see how I've got an equation with just k? So I can just solve that. So add the 2, divide by 5. K is 2/5. That's our answer, 2/5. And we knew that k had to be less than 0 because k was representing the smaller version of this line, wasn't it, AP? It's quite a long method. You might decide it's not even worth the 5 marks, or you might decide that you can do the first bit. I would recommend listing down as many vectors as you can figure out, because that's normally the first, maybe 2 marks. You could at least get 2 marks from just listing vectors. But if the simultaneous equations bit doesn't really make sense, then I wouldn't really worry, because I just think it is such a hard question. You could get the first 2 marks and then work out 3 other marks somewhere else in the paper more easily. But yeah, it is a bit of a difficult one to tackle. Okay, our final question, question 22. Ebony makes some bracelets to sell. The materials to make all of the bracelets cost £190, correct to the nearest £5. Ebony sells all the bracelets for a total of £875, also correct to the nearest £5. The total time taken to make and sell all the bracelets was 72 hours, correct to the nearest hour. Ebony uses this method to calculate her hourly rate of pay. So you can see the hourly rate of pay is the total selling price minus the total cost of materials divided by the time taken. The minimum hourly rate of pay for someone of Ebony's age is £8.20. By considering bounds, determine if Ebony's hourly rate of pay was definitely more than £8.20. Now, I know this one says by considering bounds, and by considering bounds in most cases means work out both the upper and the lower bound. However, there's a few things that makes me think differently here. They haven't mentioned the other sentence which they normally say, which is give your answer to a suitable degree of accuracy and give a reason why you rounded it that way. They haven't mentioned that. So I'm thinking, oh, is that actually the same thing? They've also only given us 4 marks. I feel like a by considering bounds is often maybe 5 marks. So in this case, I'm thinking, right, okay, I'm going to consider the bounds right now. I'm going to think about it, but I think we only need to work out one. Determine if Ebony's hourly rate of pay was definitely more than £8.20. If I worked out just the lower bound of her hourly pay, and that was still more than £8.20, then it's guaranteed that the upper bound is also even more than that, isn't it? Because obviously the upper bound is the bigger number. So I think in this case, I'm just going to work out the lower bound for Ebony's hourly rate of pay. So now I need to work out, well, what combination of upper and lower bounds do I need to substitute into the calculation? So for the lower bound of her pay, to get the smallest possible amount of pay, how would we divide it? We've got divide and a subtract. So I would want the smallest possible numerator divided by the biggest possible denominator. How do I get the smallest possible numerator? Well, I want to subtract the smallest or the lowest selling price. I'll put S for selling price. And I want to take away from that the biggest possible cost. So the smallest amount she sold it for, and then the biggest cost, the highest cost. And then I want to divide that by the most amount of time taken, isn't it? So that's the upper bound of the time. So I just like to map that out. Coming back here, we've got 875 to the nearest £5. So the lower bound for the selling price would be 872.50. Because upper and lower bounds, you always add or subtract half of what it's rounded to. Because it's rounded to £5, then half of that is 250, isn't it? And the same would work for the 190. We want the upper bound, so that would be 192.50. Over the upper bound of the time, so the time is correct to the nearest hour, so add on or subtract half an hour. Because we want the upper bound, that's therefore 72.5. So now, just put it into my calculator. So as you can see, that gives me 9, and this is in terms of money, isn't it? So that's £9.38. Let's round that to 38. That gives me £9.38. Now that's the worst case scenario, isn't it? That's the lower bound of her pay. That's the worst case scenario. So if the worst case scenario is still quite a lot more than 820, then the best case scenario, the upper bound, would also be more, wouldn't it? So determine if Ebony's hourly rate of pay is definitely more than 820. Well, yes, it is definitely more, isn't it? So you can say yes, both bounds would be more than 820, or some kind of conclusion just to explain that, the lower bound is more, so therefore the upper bound is also more. So those are a few of the topics that I think, or hopefully at this point, be coming up in paper 3 because we haven't seen them yet. Hopefully you found this helpful. Watch out for the next few days when I'll upload my predicted paper 3 as well. If you want to look at any of the topics we've covered here, then I should have videos going into further detail in those individually. Otherwise, thanks for watching this video. Make sure to like and subscribe and leave down below any questions or comments you might have.